Okay, so welcome back. So now in this example, we're illustrating the fact that sometimes we'll get numbers that are written with powers of 10, but they're not in scientific notation. And so in this case, it's just a matter of moving the decimal point and changing the exponent to the appropriate numbers, okay? So in this case here, in part A, we have 37 times 10 to the 5th power. So now we have our decimal point here, and again, this number has to be between 1, at least 1, but less than 10. So if we move the decimal point one spot to the left, we get it. But if we move one spot to the left, that means we have to multiply by one more 10 to move it back. So that means that we're going to have to increase the power by 1. So we moved one spot to the left, which means we have to increase the power by 1. So that means this is going to be 3.7 times 10 to the 6th power. Okay? Now, what about this one? So here, again, we've got something that's not between 0 and 1. So we want something that's at least 1, but less than 10. So we're going to have to move the decimal point over 2 place values, 2 places to the right. Okay? So now, if I move 2 places to the right, well, that means I'm going to have to decrease the power by the same number. So I'm going to have to decrease this by 2. Okay? Because again, I have to have this number be the same. This number has to be the same to whatever. So 0.03 times 10 to the third has to be equal to the scientific notation. So if I move 2 places to the right, that means I'm going to have to decrease the power on the factor of 10, or the power of 10 factor, by the same number. Okay? So this is going to be 3.0 times 10. Oops, sorry. Yeah, times 10. Okay? So again, well, what is 0.03 times 10 to the third? Well, that's 30. Well, so is this. Okay, so they do represent the same number, except this is in scientific notation now. Okay, this wasn't. That's it. See you next time.